Yeah, there's no questions from humans, or no humans want to interact. Unfortunately, we have to interact with more robots. So
Imagine for a moment, you've got this really state-of-the-art 3D digital brain model. Sounds impressive, right? Like the peak of neurological visualization. But what if this digital marvel, the thing that's supposed to unlock the secrets of our minds, keeps having its own kind of internal meltdown?
Right.
What happens when it's so disoriented, it like can't even remember which way it's faced, or its insides are so garbled, it just looks like a pile of digital spaghetti?
Yeah, not exactly helpful.
Exactly. So today, we're diving deep into this surprisingly human story. It's about technical frustration, but also meticulous triumph, all within the world of 3D brain visualization tools.
And it's not just about the code itself.
No, definitely not. It's about that relentless chase for clarity when things are super complex, and honestly, the almost darkly humorous quirks you find when you're trying to make a machine mimic something as intricate as the human brain.
And what's really fascinating, I think, is where we're getting this information. Our source material for this deep dive, it comes straight from the digital trenches, you could say,
Okay.
from excerpts detailing an AI agent's actual work on brain model visualization and interaction enhancements. So our mission for you, the listener, is really to pull back the curtain on this journey.
Yeah, the stuff you don't normally see.
Exactly. Transforming this complex, kind of dysfunctional brain model into something genuinely intuitive and clear. We'll hit the technical headaches, the surprising pivots in what users wanted.
Ah, yes.
And yeah, those moments of digital absurdity that honestly feel pretty relatable if you've ever fought with technology.
Oh, definitely.
Our goal here is to pull out those vital nuggets of knowledge about what it really takes to get data visualization right and nail the user experience, especially with something this demanding, like the brain.
So let's set that scene there, the initial state of this 3D brain model. The sources, they say it was plagued by, what was it, complex distortion and asymmetry code. Now, that just sounds like a visualization nightmare. What did that actually look like? Why was it such a huge problem for anyone trying to understand it?
It was essentially visual chaos. Like, imagine trying to read a map, but the continents are all warped and overlapping, maybe even shifting around.
Right, useless.
Pretty much. This complex distortion and asymmetry code, it meant the model wasn't clearly visible at all. Its basic structure, especially the two hemispheres, they were just obscured.
So if you're a researcher or maybe a doctor.
Yeah, trying to study neurological activity, trace pathways, it was a non-starter. It's like being handed a blueprint for a house, but the walls are kind of see-through in some spots, solid in others, and the rooms don't really line up properly.
You know the info's in there somewhere.
Exactly, but it's fundamentally unusable, and it just highlights that basic principle, right? In data visualization, if you can't even represent the underlying data accurately and clearly, the whole tool just falls apart.
Yeah, its whole purpose is gone.
Right.
Okay, so that makes perfect sense. If you can't see the basic layout, you can't analyze anything complex. So, job one, fix the visual chaos.
Right. First big structural overhaul.
The AI agent gets to work, starts pulling out that complex distortion and asymmetry code, and replaces it with something much simpler, more elegant, simpler symmetric ellipsoid for each hemisphere, separated by a clear gap.
Sounds like a necessary digital facelift.
Precisely. That first phase was all about bringing order out of that chaos. The agent's initial thought, quite logically, was, okay, let's make a structured visualization. Let's not rely on random data points.
Use distinct shapes, clear elements.
Exactly. Define each brain part clearly. The assumption was clarity equals rigid structure, which, is often the first instinct in design imposed orders. It's neat.
Here's where it gets interesting, and yeah, a little bit ironic. Maybe that dark humor creeping in.
Uh-oh.
Just when the agent is tidying everything up, making this beautiful, symmetric, organized brain, the user drops a bombshell.
They didn't like it. They wanted the random points back. It's like you meticulously clean a room, and the owner walks in and says, no, I preferred my artfully arranged clutter.
Oh, wow. Yeah, that happens.
So what kind of challenge is that for a developer? How do you take something you just designed for clear structure and reintroduce randomness without, going back to the original mess?
Well, that's the classic agile development headache, isn't it? It shows that sometimes the technically perfect or most logical solution isn't actually what the user needs or wants.
Right. User knows best. Sometimes.
Sort of. So the agent couldn't just slap the old distortion back on. The task got really nuanced. It was about making sure Different parts of the brain are still clearly distinguishable.
Yeah.
By adjusting the size, color, or positioning of the random points within each brain region while still maintaining the randomness.
So controlled chaos.
Exactly, controlled randomness. It needed a pretty smart algorithm to get just enough randomness to satisfy the user, but not so much that it hid the structure again. It's a critical lesson, really.
How so?
Successful visualization isn't just about showing data. It's about showing it in a way that fits how the user actually works and thinks, even if that seems, well, contradictory at first.
Okay, so the agent pulls it off. This fascinating balance. A brain model that looks random, but is somehow clearer than before. Distinct regions, color-coded hemispheres and lobes, but still keeping that random vibe.
A triumph of flexible design, really.
Definitely. But, okay, let's move on. Another digital headache. And this one might hit closer to home for anyone who's used buggy software. The view persistence problem.
Ah, yes, the forgetful interface.
Totally. You're navigating this now visually improved 3D brain. You click buttons, show you the front, the side, the top. It changes. Perfect.
Under a second.
Exactly. A few seconds later, poof, it just reverts back to a side view. Like, this digital system has severe short-term memory loss. It just stubbornly refuses to do what you told it.
And it's more than just annoying, right?
Yeah.
It's fundamental. It breaks user trust. It's amazing how quickly a seemingly small glitch like that can just undermine the whole tool's usefulness. So the agent had to dig deep, investigate the code that handles the view orientation and persistence.
Find the memory leak, so to speak.
Sort of, yeah, to ensure that the selected view remains active until another button is pressed. It's not just a visual quirk. It hits a core UX principle, reliability.
If it doesn't do what you tell it.
Consistently, predictably.
Yeah.
No matter how powerful the other features are, it becomes frustrating, unreliable. Ultimately, people just stop using it. They abandon systems that don't respect their commands.
Right. It's a classic case of a small nagging bug just derailing everything. So the agent's fix was targeted.
Yeah, straight to the logic controlling the view state. Had to overhaul it. Essentially, teaching the model to just remember which way you wanted to look at it.
Hold that thought.
Right. Hold that view until you, the user, decide to change it again. No more digital defiance. No more frustrating snapbacks to a default you never asked for.
It's the kind of fix that, like, you don't see it, but it totally changes the experience from maddening to just smooth.
And it worked. The agent fixed the view persistence issue, so the selected view, like front, side, or top, will remain until you choose another instead of automatically reverting. It just shows, that consistent, predictable interaction isn't a luxury. It's absolutely essential, especially for serious tools used in analysis.
Okay, so now the brain model looks right. It stays where you put it, smooth sailing.
You'd hope so, wouldn't you?
Uh-oh. But then,
Yeah.
along comes a classic developer's nightmare, like a sudden silent killer. A JavaScript error related to an undefined function called onWindow resize.
Oof. Yeah, that's never good.
Right, this isn't a visual glitch or a weird behavior. It's a critical system-level failure. It's like a crucial piece of your car engine just vanishes when you hit a bump. The whole thing could just seize up.
So why does that happen? An undefined function error, especially linked to resizing a window.
Yeah, what's going on there?
The basic issue was the code was trying to call a function, this on-window resize function, that just wasn't defined anywhere. It didn't exist in the script.
Like instructions pointing to a blank page.
Exactly. Like an instruction manual says, if the window size changes, do action X. But there's no description, no code for what action X actually is.
So when you resize the window.
Crash or errors pop up. The program tries to follow non-existent instructions. It really highlights how fragile, complex software can be. One missing piece, the whole thing can fall over.
Wow. A seemingly tiny oversight with potentially huge consequences. So what was the immediate fix? The emergency intervention?
Well, the immediate and correct response from the agent was define that on-window resize function. Give it a job to do.
And what job was that?
Its job, now that it's properly implemented, is to update the camera's aspect ratio and the renderer size when the window is resized. Basically, make sure that when you drag your browser window bigger or smaller.
The 3D brain inside scales properly.
Precisely. Without getting stretched or squashed or just erroring out. It's fundamental for responsive design in any graphics app.
Yeah.
You need it to handle changes in its display environment gracefully. Without that fix, the app would break every time a user just adjusted their view.
Okay, so we've talked about distorted brains, forgetful brains, brains that crash when you resize a window. Each fix From the visual clarity stuff to the deep code integrity, it might seem like just another technical hurdle. But let's connect this back, the bigger picture. Why does all this painstaking work matter to you, the listener? What's the ultimate point of making a digital brain model this precise, this reliable, this user-friendly?
Yeah, this is where you see the real impact of all those technical details, right? This isn't just about making pretty pictures. It's about building a truly robust 3D visualization tool for the brain.
And the applications are serious.
Oh, absolutely. Likely designed for critical stuff like studying seizures, analyzing neurological activity, maybe even planning surgery. Imagine a neurosurgeon trying to pinpoint exactly where a seizure starts.
Or a researcher mapping disease pathways.
Right. If the model they're using is distorted or keeps resetting the view or crashes, it's not just annoying. It's a genuine barrier to accurate diagnosis, effective treatment, maybe even to groundbreaking research. All this work we've discussed, it transforms what could be a chaotic, unreliable data dump into an actual invaluable scientific instrument.
Exactly. All these fixes, the clear hemispheres, the view that finally listens to you, the stable resizing, it's all about taking overwhelming, complex brain data and making it accessible, making it intuitive.
Turning data into insight.
Yes. Empowering users, whether you're a seasoned neuroscientist spotting tiny anomalies or just someone curious, exploring how the brain works. It lets you explore the details effectively without fighting the tool itself. It's that painstaking, often invisible work that makes the difference between a confusing mess and a powerful tool for discovery.
Couldn't agree more.
So we've tracked this digital brain from, well, its chaotic beginnings to being this well-behaved, clear, responsive tool. It's really a testament to the continuous effort, right? The debugging, the user feedback, everything it takes to make complex information genuinely useful.
There's a certain, maybe critical irony there, isn't there? How much effort goes into perfecting the digital copy?
Yeah, Kathleen.
And it maybe raises a question for all of us listening. Given how much meticulous effort goes into debugging, enhancing, refining a digital brain, complete with its own identity crises and memory lapses to make it understandable and reliable, what does that tell us about the challenges and maybe the endless, overwhelming fascination of trying to truly understand the complex, messy, wonderfully unpredictable real one inside our own heads?
That's a deep thought to end on.
Maybe even our own organic brains could use a little debugging now and then.